we go. Okay. I think I've got things ready now. All right, so first time streaming. And so I'm going to be doing all sorts of goofy things, I think. Wait. Warning. I'm on a low bit rate. Okay. There's not too much I can do about my bit rate right now, so I'm hoping that everything will just kind of go smoothly here. I'm getting a little warning here. So I'm going to go ahead and start everything that I plan on doing. Actually, I'll hit record here as well, just in case there's a problem with the YouTube stuff. So I'm going to be doing a little bit of updates on For All People. I have created a quick little website here that you can access, pages.structuralpython.com/streams/1-forallpeople, and I've got that up on my screen here. So if you wanted to sort of get a little bit of background on everything that I'm going to be working on today and how For All People works, you can read this and give you a little bit of information. I have a tendency to try to over-explain things. I'm going to try not to do that and just kind of talk my way through as I'm doing things. So I'm going to start off just by opening up the VS Code. Oops, there we go. Clear up all my Jupyter stuff. Open up VS Code and open up the repo and just do a little bit of sort of check in to see where everything is at, because it's been a while since I've sort of really gone through things. So open my repo on my local. There we go. And I'm going to zoom in a bit here so it's easier to see. Okay, there we go. Ignore all that. Okay, so let's clear off all these guys. And let's get a sense of where we're at here. Docs. Here we go. The main For All People repo is organized into a few files and then a directory of tests and a directory of environments. Now, I think I'm going to spend some time cleaning this up and maybe move the tests out of the main repo, add a source directory into For All People here. For All People is like the very first package I've published. And so there's all sorts of decisions that I made at the time that reflected my lack of knowledge and lack of experience, and that I've been sort of meaning to kind of catch up on and fix. One of those is the init.py file here, which is typically not really used for like a place where you actually write code. But I wrote the sort of the main code of For All People in the init.py, so that way it sort of all gets run immediately at the time of import, because I didn't know at the time how to sort of do that otherwise. So the main tool, the main sort of class of the For All People Units library is this class here called physical. And it has these 5 attributes here that I've described in the pages there. And so these are the 5 attributes that just sort of define how a unit is sort of recognized and how it's communicated and how it's calculated with. The problem that I have right now that one of my students brought up in Python for Structural Engineers is that there is a weird behavior where when you raise, if you sort of negate a unit by raising it to a power of 0, then the units don't get sort of canceled out. Let me show you what I mean. I'm going to open up a new session in Jupyter here, and I'll just open up a new notebook and import For All People and go from there. Here we go. So let's go open into my PyCode directory where I keep just a bunch of notebooks, and I've got a little scratch directory here where I just kind of put junk, whatever. So let's do that. PFC environment is an environment that I have where forallpeople is installed, and let's just do import forallpeople. And I will do it as import forallpeople as SI, and I'll say si.environment structural. This is just sort of the standard way that you sort of start using forallpeople. So now I've got all of my units available under the SI namespace, so si.kilogram, and because I've loaded the structural environment, I've got si.kilonewton and other derived units that I've sort of pre-programmed into this structural environment file. The problem here is that it would be convenient in some cases to zero out a unit by raising it to the power of 0. Oh, that worked. So, that was, oh, it's not, oh no, it didn't work actually. Let's take a look here, because the output is being displayed in HTML, and so this is still being recognized as, that's right, it's still being recognized as a unit. The units actually are zeroed out, but we still have a physical instance, which is the problem, like that. So we still have a physical instance. The idea is that if I had a kilonewton and I divide it by a kilonewton, then it zeroes out and I get the number 1 as opposed to a physical instance, a physical instance of the number 1. So it's actually a number in Python, a Python number, a float. So this guy, I want to have this actually zero out to a value of 1, but not 1 as a physical, but 1 as just a float. So that's the bug I'm trying to fix here. So let's load that up. So the Python objects, Python classes have the ability to define their own behavior, how they interact with the Python language themselves. And this is controlled through what are referred to as magic methods, these guys here, or dunder methods, because they start with double underscores and end with double underscores. So there is a method name to describe how the object or the class is supposed to behave when it's used with the equality operator. So if I had A equals 5 times si.kilonewton, and then B equals 5 times si.kilonewton, we can check to see if they're equal by using the equality operator, and the behavior that gets executed between A and B when I use the equality operator in Python is defined here in this equals dunder method. The reason we're called magic methods is because the only reason that these things work is because they have a magic name, the name that's reserved to define the behavior of how the object works with the equality operator in this case. So there are a variety of these magic methods. This is to describe what you do, what the objects do when they are used with the greater than operator, greater than or equal to is less than or equal to, the add operator, the addition operator, the plus operator. It defines the behavior there. So when I add two units together, they add the magnitudes and they keep the same unit. All of that behavior is programmed into the add method here. So how does add work? Well, it checks to look if the dimensions are the same, and if it's the same, then just add the values together and keep the same dimensions and everything as it is. Keep everything as it is of the first value. So that's this guy here. So if we're adding together, this is the first value. So whatever the properties are of the first value, propagate through to the end value here. So its value gets added to the other value, but then its dimensions carry through, and its factor, its precision, and its prefix status gets carried through, not the other one. So I had to make a decision, and that's how I decided to do it. So that is what happens if the dimensions are the same. If the dimensions are not the same, then you can't add between dimension units. So let's say we made this meters, and we tried to add them together. We get this value error, and you can see the exact wording of the value error here, right? Cannot add between self and other, and it displays self and other. Self is the first, other is the second, as you can see. Now, the other behaviors are if the try other equals self factor, and then right. So other equals other divided by self factor. Right. Okay. See if the factor works out, and then the other one here is subtraction. Multiplication is sort of the more interesting one here because this is where we can actually zero out our dimensions. So adding together, you can't ever sort of zero out your dimensions because you're always in that same unit, right? But if we were to say do kilonewtons to the -1, actually no, let's just do kilonewtons squared. Or just do kilonewtons like that. And so we did A times B. Run the cell above. And now we can see we got kilonewtons squared. And so in the kilonewtons squared case, we've got the dimensions attribute now are equal to 2 times the regular dimensions attribute of a kilonewton. So A dot dimensions like that. So a kilogram meter per second squared. And now we've got 2 kilogram, now kilogram squared meter squared per second to the 4th. So that is what we defined as a kilonewton squared. Now, in order to do that, multiplied together, we have to add the vector dimensions together, do a vector add of the dimensions. So we add the dimensions of the self to the dimensions of the other. We check to see if we recognize what the resulting dimensions are. And then if everything works great, we just display the new value. We calculate the new value as the self dot value times other times value. And then we return the new value with the new dimensions with the new factor and the precision. But if the new dims is equal to dimensions equals 0, then we just return the new value as a number, not the, what's the word? Not the physical. So we basically want to add this check to power, which is what defines the behavior when we raise it to a power here. So you can see here when I wrote power, I did not include that check. I didn't think of it at the time. And then one of my students brought it up and said, hey, it doesn't work like that. And I said, yes, you're right. It should work that way. So we have to do a check here and very similar here. Now, there's more to this, I believe, because if the new dimensions are 0, return the new value. Otherwise, return the value here. Now, there's another scenario here is if I do a bunch of checks here. And division is the same as multiplication. But let's just go up to multiplication because that's sort of the easiest one, the general case. We check to see if it's a number. So if the physical instance is a number. Now, in the case of raising to a power, we can't raise a physical to the power of another physical. That's not an operation that's defined in this library, but so in our case, we'll always be raising a physical to the power of a number. And so that check we don't need to worry about. If instance other is physical, else, here we go. Now I'm just looking to do a check here to see if there's something I need to do about the factor. If I'm raising it to the power of 0, then actually I don't really care about the factor because it's coming out as a number, but maybe we want the number to be returned in the units of the factor. Ooh, that's an interesting design decision. Now I've got to think about that. All right, so to start off, let's just copy this guy. If new dimensions equals dimensions, return new value. So like that. Let's go down to POW. All right, if is instance number, self.value is going to be raised to the power of other. The new dimensions are going to be multiplied by other, which is going to be a scalar. And so we're just going to get a vector multiple of the dimensions here. And now I'm going to do a check, like a fraction. Yeah, fraction power, new factor if it's a right. Okay, so if we are getting a fractional power, then we're going to change the factor as well. So yeah, so we're scaling the factor at the same time. So in this case, so the new factor comes out, new value. So I think I want to do a check right after all this stuff. So if the new dims, oh look at that, I used this different variable name above and below. Keep it the same one here. If new dimensions equals dimensions 0, then return new value. Now, I don't know if I always just want to return new value or if I want to return factored new value. I think I want to return the new value times the factor because that way you're always going to be getting sort of the numerical answer you expect. Now, what does that mean, the value versus the factor? Because The physical unit here, all these 5 attributes here, are stored assuming that everything is in SI base units. So there's a value that gets carried through every calculation, and that value is carried through in SI base units. So if we looked at A is 5.kilonewtons, we did A.value. It's not going to be, I don't think it's not equal to 5, it's equal to 5,000 because the value of a kilonewton is 1,000 newtons, obviously, and the value is stored in base units, so they would be in newtons. So if we said A.repr, see all the components, we see the value is 5,000. This is the dimensions. It has a factor of 1, a precision of 3, and it's got no prefixing attached to it. So the what I want to do then is I'm going to want to multiply the value by the factor. So when the value by the factor is, I want to do the value by the factor and then by the prefix. Because if you've prefixed this value, then you're going to say, yeah, you're going to want to have it come out like that. All right, so let me explain what I'm talking about here. So A, it's in kilonewtons. Now, there are situations where you might want to have it prefixed to a certain value, certain kinds of prefix. And so let's say you wanted to prefix it to meganewtons. Now, A is going to be prefixed to meganewtons regardless of the magnitude of the value. So this way now we can keep, and then if we did, let's see, is B still in kilonewtons? I don't think it is. It is. Okay, let's make sure that's the case by rerunning that cell. And then if I add the 5 kilonewtons to it, that prefix is not propagating through. Okay, so it looks like we got 2 bugs here, but this, because we're doing A and taking the prefix of A and carrying it through, then I would expect to see that is in 0.001 meganewtons. So maybe that's the second bug to fix here. So that prefix should propagate through. But that's sort of the idea there. Now, if you had A prefixed, A equals A.prefix. Yeah. Oh, I know what happened. I ran that cell. Here, let me break this cell up into 2 pieces. Oops. Okay. I ran this cell, and that reset the value of A, and then when I added them together, A didn't have a prefix. So let's do A.prefix. There we go. Now if I add it to B, which I know is in kilonewtons, there we go. That's the behavior I was expecting. I reran this cell up here and reinitialized A after I had set the prefix to it. So A plus B equals 0.01 meganewtons. That's the exact behavior. Now when I do, if I were to then take the float of this number, like turn this, just ignore all the units and just turn it into a float, I've programmed it so that way you see the magnitude that you sort of set up, right? So you decided you wanted a prefix on it. So when you turn it into a float, it's the prefixed value instead of returning the sort of the base value, which you can always get by doing .value. So I think the behavior to do here will be to mimic what happens with float. And so if the dimensions go to 0, we would want the prefix value to come through, and that way it looks like just the dimensions got zeroed out instead of having the value come through. And similarly, if we had, say, C equals 5 times SI.pounds, and then we had, we did C, and then we did float C. Here, let's look at C.repr. Here's the value of it in SI base units. Here's the dimensions of it, and it's got a factor attached to it. And then this value times this value is going to give you this value. So the C.value times C.factor is the value that maybe we want to have returned here. Because if we zeroed out C as pounds and we took out the dimension, then we'd want it to be able to we want it to say 5 instead of 22.24, blah, blah, blah. So that's, I think, the decision I'm going to make here. So in order to get that, I've got to multiply it by the factor. Now, the factor is set to 1 if there is no factor. So multiplying it by 1 will just return the value that one's expecting. And then the other thing we have to do is to prefix it. So let's first off deal with the first one, because I don't remember if I've got a convenient way of applying the prefix, but I must. I just haven't been here in a while, so I'm going to take a look. So instead of saying return new.value, I'm going to say return new.value times new factor. There. So let's save that. Now, when I go back to my notebook here and rerun it, like because I'm in my PFSC environment, I'm not in my for all people development environment here. Maybe I should go into my development environment. There. Now, when in this environment, any changes I make to my code, which is in a different location than wherever this notebook is, I can restart my kernel. And then when I run everything and import it, it will import the new version here. A way to sort of make life easy so I don't always have to restart my kernel and re-import is to load up the auto reload extension. Load extent auto reload and set it to auto reload option 2, which is to re-import on every cell run. Now that I've run that as my first cell, when I import for all people, then I should see the updated behavior now. Oh, look at that. Here we go. Now we're getting somewhere. But there's an oversight in my decision here. So return fraction 1/1. That is correct, except I don't want to see a fraction. So why is it returning a fraction? Well, that's because I forgot that I updated it so that the factor is always expressed as a rational, a integer ratio. And that was the purpose for that. It was for retaining precision, because as you do multiple operations, so you do 5 pounds divided by 3 feet times 5 inches squared divided by another, by a meter, then that factor gets sort of jumbled up. And it gets carried through all the factors there, but at the end of it, you end up with a factor that sort of has gone through multiple floating point operations because we're multiplying the factors together. And so as you do multiple floating point operations, you lose precision, and then it's hard to look up a float value when the precision might be slightly off of a value that's being expected. So I decided to try and use the fractions to store that factor as a fraction, and it's an integer ratio. So what does that integer ratio look like? Here is, let's pull up one of the environments. Here's the structural. And so pound inch. So I'm expressing 12 divided by this number here, which is a float, but this is the definition of the pound to kilogram. And this is the definition of the acceleration of gravity, meters per second squared, and then this is the definition of a foot to a meter, and an inch to a meter is defined as 12 divided by that number. So this is sort of the ratio that's being sort of calculated, and it gets carried through as the integer ratio. So the factor is always coming through as a float, but then when I ask to see it and I show it in the representation, then I change that into a float because it just makes more sense here. Where's my pound? Here, c.repr. Oops, I restarted my kernel. There we go. So the factor, for the representation of the factor, I put it as a float. So what I want to do is I need to float it out. So I'm going to convert my factor to a float and then carry it through. So I'm going to back down to the def method. Factor, now, maybe what I should do is multiply it by the value. Carry it through, it'll carry through as a fraction. But how about why don't I float the fraction? Float the final result here. That way I sort of get to sort of retain precision of the fraction the whole way. And then let's just do that step, and then I'll go back and worry about the what's it going to say? The prefixing. So there we go. So let's do that. Let's go back now and clean up this notebook a little bit, perhaps, because there's a ton of junk here now. Let's see. si.environment, si.kilonewton. Oh, let's rerun that from top to bottom. Here we go. si.kilonewton. It looks like now I'm getting my 1. There. So I'm not getting, 1, I'm not getting 1,000. And so this way it's floating out the actual sort of value that you perceive 1 kilonewton as opposed to 1,000. So that's looking like it's working well. So let's do it with SI.pound. Comes out as 1. Great. So that's working sort of as we're expecting now. So now the only thing left to do, I don't need to worry about the prefix because it's already been auto-prefixed because I'm using, yeah. I think that's all working out. Because like kilonewton's coming out. Let's take a look. Because I'm floating the number. Let's take a look. New value times new factor. Now, new value here, I was expecting new value is self.value other. Right, it's, right. Self.value is coming out as 1. Doesn't matter. I don't have to worry about any of that because when you do it by 0, of course, anything raised to the power of 0 is going to be 1. So there is no problem here. Everything is going to be working out great because raising it to the power of 0, 0 is going to get 1. So that works beautifully. And so the idea, so the motivation behind this is that you could multiply, you could have, okay, so here's the big motivation. Let's say we had a setting, apply units equals true. And if apply units is true, then apply units, this is a behavior in Python, apply units is also equal to 1. So since it's literally equal to 1, we can say si.pound to the power of apply units. And so then we can say 5 times si.pound to the power of apply units. So we say applies units is 0 or false. Now we're not applying the units. There we go. So now we're getting the behavior we expect. So let's now go in and put in a test to validate this. Now, the one thing that I should have done is actually I should have written the test first. So I'm going to do this. I haven't committed any changes yet. So I'm just going to comment out this set of lines here. And now I'm going to go through and write my tests. Now, before I write my test, I'm going to go through and check to make sure that my test suite just runs on its own and that I have no surprises. So I should be in the exact same clone as the same state as the repo. So I'm going to go ahead and activate my development environment, my conda for all people environment, where I have this repo installed. So now I'll go to my directory, code/forallpeople, and I'm on a misc fixes branch. Oh, I didn't even check to see what branch I was on. What am I doing here? Let's open up GitHub Desktop so I can get a visual for all people. There we go. Where are we at? Connor Firster. Oh, doesn't seem to have it in here. Let's load it in. See how long it's been since I've worked on this. My apologies, people. For all people is actually really important to me. And so I really want to do a lot of work on it to make sure that it's tip-top. Okay, so misc fixes seems to have no changes on it right now. I'm going to get off of this branch. I'm going to create a new branch. Leave my changes on misc fixes. There we go. I'm going to create a new branch here. I'm going to call it fixes / power of 0 to floats. Something descriptive so that when I go look at what happened to the branch and I remember what it is just from looking at the name. So now let's bring the changes over that I have stored in that misc fixes. So I'll choose a branch to merge into it. I'm going to merge in misc fixes. There we go. Cool, merged in, publish the branch. That's going to push it up to GitHub. Now, if you want, you can like follow along on the repo here live if you're following along in the on the stream. Let's pull up the browser here. So github.com /Connor Firster /forallpeople. This is the repo here. And now you see those changes. I got misc fixes, now I got fixes power of 0 to float. So you'll also notice all these horrible names here. This is before I learned about proper branch management. So now I'm going to start doing things in a little bit more of an organized fashion here. So fixes power of 0 to float. This has the change that we just made, and you can see that going into init.py, and you can do a search for Control F, def, _pow, and you can see, oh, you won't see it there because we zeroed that out. So wait a minute, I commented it out. It should still see the commented here. So there's something, let's see, something's not quite right here. Let's see. Fixes pushed. Let's go look at my code. Do I have it there? I don't. Okay, so that explains some stuff. Did I commit it? Oh, maybe I didn't commit it on misc fixes. Stashed changes. I didn't commit it. Here we go. Let's restore the changes. Commit to mix fixes. Now I'll merge it into power of 0 and choose a branch to merge into mix fixes. There we go. Now I'll push to the origin. And now I should be able to refresh the page here. And Control F, def, pow. There we go. There's the changes. Okay, so now I know where I'm at. Let's continue on here. So I'm going to do git status, and I'll see my branch change and my prompt. They've got changes that have been committed. That's why it shows green. And I'm going to run PyTest. And there we go. All my tests have passed. So now I'm going to write a test to intentionally fail without that change. So tests. Test for all people. Look at, here's test float. Here's all the places where I do this. Now I want to update this because I'm doing this thing where you'll see all this yellow underlining here. I've since sort of adopted a better practice, which is import for all people is si.environment, units. And when you're writing code in a module, I highly recommend not using this sort of top level import here, which is funny because I'm not actually, I'm doing top level equals true. So I'm pushing units into the top level namespace. And that which means they're being dynamically generated in the namespace, and VS Code does not recognize them because they don't follow a regular import process. So a better way of doing this would be to change all these to si.pound, si.foot. But I think I didn't do that at the time because I was like, oh, it's too much typing. But now I've got this thing where I've got yellow everywhere. So I'm going to update that at some point, not today, where I'm going to change all those to si.foot, si.pound. So that way I don't get any of this yellow stuff here. So let's see, test pow. Let's see, where do I have test pow? All right, so let's add some test cases here. So these ones pass. These exhibit the behavior that I want. And so when I do a Newton squared, then I get a new physical with the value of 1, and then with these dimensions. Great. So what I want to do now is check to see if I assert, let's say, foot to the power of 0, then I should get 1. Now, I expect this, like I said, I expect this test to fail right now. Okay, didn't fail. So what's the haps? I think it might be, I'm not sure if it's, it should be installed in that environment. So I'm going to do a quick check here to make sure I'm installed, flit install --pth file. So that way I've got an editable install here for all people. And then I do PyTest. Okay, it's still passing. Assert foot to 0 is equal to 1. And let's just make sure I'm running the code that I think I'm running. This is something that I tell my students, is that when you're encountering behavior they're not expecting, like a bug, or in this case, you're expecting a certain behavior that's not happening, always validate that the code you think you are running is actually the code you are running. So I'm going to assert false, and this should raise the error just on the false assertion alone. So if this still does not fail, okay, perfect. So it's hitting the assert false. Yes, the code I'm running is the code that I think I'm running. And now let's check out that behavior. So foot to the power of 0 should equal 1. So let's do this. I'm going to keep this, actually, I'm going to do this assert false. And when you've got a failing test in PyTest, by default, it will print out anything that you've got printing here. So I'm going to do print, and I'm going to print the type of ft to the power of 0. And I should expect that to see a physical instead of a float. So I'm going to run the test again, hit the up arrow to re-execute the last command. And yes, okay, so look at this. I'm getting a physical here. So that is, so I cannot test for the 1.0 by using the equality operator alone, because that was a design decision that I made to make it sort of easy to sort of check magnitudes of sort of numbers to your expected value, right? So 5 is equal to 5 pounds, which I don't know if is a behavior that I still want to keep. Because you don't want 5 to be equal to 5 pounds and also be equal to 5 kilonewtons, because then that breaks. It implies that 5 pounds is then equal to 5 kilonewtons mathematically. So let's just check to see if that's what I did originally. 5 times SI dot pound equals 5. Good. Okay, so that's false. Now I have a feeling though it's checking the value attribute. Now if I make this kilonewton, there, that's wrong. Okay, so it's checking to see if the dot value attribute is the same, which is good, but it's better, I should say. It's still a little ambiguous though, because that implies that, let's see, 5 times SI dot pound equals 5. Okay, good. That should be false. All right, so false, false. And so then if I've got okay, so the reason it's coming through as true is because, again, when we raise it to a power, it's zeroing a power of 0. It's going to zero out the factor to 1. It will sort of revert the factor to 1. It will change the dimensions to 0. And so the factored multiplied by the thing, and then it's also going to do the value to dot 1. So it's checking, so it is doing a behavior that makes sense. It's checking that the value, because the value gets raised to the power of 0, the value is set to 1, and because it checks the value in the equality, then that's the behavior we're seeing. So I need to do a more thorough check to see if the behavior I'm getting is what I'm wanting. So I'm going to do this type checking here. So I'm going to validate that instead of, I'm going to check the type. So let's do that. So I can do 2 assertions here. Assert that foot to the power of 0 is equal to 1. That should be true, but I don't want to have that just be on its own. That seems like a useless test. I want to say to make that as part of a sort of a compound test, and that the is instance, the type of foot to the power of 0 should be a float. Okay, so now let's run that test. See how that fails. Excellent. Oh, assert is instance expected 2 arguments, got 1. So what did I do here? Is instance, oops, I got too many brackets. There we go. And then I got to take this one out. And so I don't need to do that. I'll just put that here like this. There. Run that test. Yep. False equals is instance. Yeah. Perfect. Good, good, good. All right. So now I should be able to make this change. Let's do a commit because we got 2 separate things being done here. Tests. Added test for incorrect behavior. There we go. And now let's add in uncomment with the correct behavior. Save it. And now run the test. Passes. Good. Okay, so that's what I want. Let's do a couple other tests here with a let's do another test here with just kilonewtons, just to kind of cover off two bases here. Let's do it with kilonewton. There you go. And now rerun it. And that still passes. Excellent. So I'm going to call that good. Fix updated behavior of POW to return a float when dimensions equals 0. Okay. All right. So I'm going to open up a pull request on GitHub for this change, and I'm going to merge it back into the main branch. I'm happy with that. Unfortunately, I don't think an issue is raised for this. Let's do a quick search for the issue if there is one. I maybe should have opened up the issue. Let's see, POW. No, doesn't seem like there's an issue for that. So we'll go to pull requests. Oh, good. Yes. I'm gonna let's merge that in too. Let's do that. README updated with badges and links to documentation. PyPI project updated with document. Thank you for that. Unfortunately, I sat on this, and let's merge those pull requests first. Many thanks. Add the comment first. Confirm the merge. Let's do a quick check though. Let's take a look at everything. See all the changes. All right, so what are the files that have been updated? README and PyProject.toml. Updated shields. Nice. Documentation link. That was one of the things I wanted to do today, but this wonderful person has done that for me. Thank you so much. PyProject.toml, the changes, URLs for the documentation. Nothing else has changed. Version should not be in there because the version is dynamic. So what am I going to do is, let's see. Actually, I'll just leave this, give this person the opportunity to do this quick fix. This pull request. One small change needed. Please remove the version specifier from PyProject.toml. It is dynamically generated by Flit. There you go. All right, add a single comment. All right, so that person will get a notification of that. So we'll leave that open now. Won't pull that. We'll open this pull request. Okay, create pull request. Add a test. Now, I don't think I've got a whole lot of, I don't have any of my testing set up on GitHub Actions yet. That's, again, something I need to bring in here. But because I ran my test locally, I am fine with merging that into the main. So now that is part of the main For All People repo. So I want to update that, get the docs updated on the README, but I'm going to wait till that pull request is complete, and we'll do that shortly. But now I am going to want to do, let's do a release with this new version on it, with these fixes in this new version. So go back to For All People. Now I've got releases here, but I don't have a workflow, GitHub Actions workflow for the releases. I've got a GitHub Actions here for publishing the docs when the docs are updated, but I don't have a GitHub Actions workflow for publishing to PyPI automatically when I create a release. So I'm going to go ahead and do that. Like I said, this is a lot of work needs to be done here. Oh, dismiss. Here's what we're going to do now. Is I'm going to go, because I've done this recently with other repos, I'm going to go into my code directory where I've got all of my repos that I work on, and I'm going to just copy and paste the handcalcs GitHub Actions file. Let's see here. GitHub workflows, PyPI, Python publish, and Python PyTest. I think I want both of those. So now let's go ahead and create a new branch. So I've merged this in. I can delete this branch. Let's go to main, and I'll fetch the origin. It'll update with all the changes that have just been merged in. Here we go. So now my main is current, and I'm going to delete this branch here. Yep, delete on remote. Okay, now let's create a new branch. And this is going to be, I'll call it chores. It's not adding a feature to the project. It's just something that I need to do. Chores, add GitHub action workflows, test, publish. Okay, so now I've got that going. Let's pull this up. And I'm going to, actually I don't need this VS Code to do this. I'm just going to go ahead and paste these files into the repo directly. So handcalcs, GitHub, handcalcs for all people, GitHub, workflows, paste. So what are in these YAML files? It says to run this test on all operating systems on these Python versions. Is going to install UV, which is a faster pip replacement. It's going to install all of these test dependencies for handcalcs, but I don't want all of these for handcalcs. I just want for all people. I don't need any of this stuff. I just need PyTest. And then I'm going, and black. So I want to check to make sure that everything is formatted with black. So it's going to check it, and then it's going to run PyTest. So it's going to check black first, and then run PyTest. And if that PyTest runs and black says that no files need to be updated, then that is all we need. So that's PyTest. That's what I want there. And now let's do publish. All right. Now I believe there shouldn't be any changes here. Flit, upgrade pip, flit install the package, flit build. Make sure I can install it, then build it, and then publish the package with GitHub Actions, and then to use my token from my repo, PyPI token, which I already have previously set up, which is my, when you sign up, when you get an account with PyPI, the Python Packaging Index, you, to publish, they give you now a API token, and you put that API token into your GitHub repo in secrets environment, and then it just pulls that internally from GitHub, so you don't actually have to include your API token into the actual file. It just sort of does evaluates this variable for you. Okay, so those are in there. Let's update now. This guy. Chore. Added GitHub Actions for test and publish. And let's do a pull request there. We are getting for all people modernized. Add GitHub Actions for test and publish. Great. Let's create the pull request. No changes other than the creation of these two files here. No changes to any other files. Okay. And now these files exist. It's going to actually run the tests in the repo. So Python testing sort of take a minute, but I'm expecting this a bunch of red here because I think primarily is that black is running. That's a test black formatted. No. Oh, path handcalcs does not exist. My bad. I've got an error in the actual file that I did not update. So let's go ahead and fix that. GitHub PyTest, because it's installing handcalcs, black handcalcs. That's what I want. It's doing black for all people. Now it's also going to format my test directory which not intended. But I don't think that's a big deal on for all people. It's a big deal on hand calcs, but not for all people. So I'm going to say that's okay and make it push. Oh, yeah, that's right. Okay. And go back to this pull request. Now I've changed it, and it just updates the pull request live. So now it's going to run the same test again. And I'm expecting to still see red, because even if black does run, then I'm going to say, yes, it would reformat these files. Okay. So 4 files would be reformatted, 3 files would be left unchanged. Now, I'm not going to let this stop me from merging this, because I don't want anything else, any other changes to be in this pull request. I want it to literally just be adding these files and close it out. I don't want, for example, in order for this to pass, I'd have to run black on the code base, and then black would make a whole bunch of changes to my files, and then I would see these 2 files get added, plus a whole bunch of other stuff. And I don't want to have all that in this pull request. So I'll do that separate as like a Blackify code formatting thing. So confirm the merge. There we go. Now I can go ahead and delete this branch. And turn up the volume. Maybe could we turn up the volume? I'm seeing there's questions here in the chat here. My apologies. New here. So I'm trying to. Now I don't, Carl. I don't see your other message. I just see like 2 messages, and it's not scrolling the darn chat screen, which is a bummer here. Here, I'll open up YouTube Studio and see where we're at. Oh my God, there's a whole bunch of chat here. Let me take a look. I'm just jabba, jabba, jabba. All right, say, can we turn up the volume? You know what? Does that make it better? I just rotated my mic. Maybe it was rotated away from me. But let me take a look also at my levels. My levels are maxed out, so you should be getting good audio. Let's see, unless there's something else I don't know. So let's go back there to my YouTube Studio. Where's Studio? See if there's anything else here that I can address. Hey, I've been using your package for designing concrete structures for my final project. Thank you so much for this. Tomorrow's my final present. Hope I pass it. Yeah, I hope so too. Aren't we just trying to solve if other equals 0, return equals 1? Oh, that's a nice fast way of doing it, if other equals 0. The reason I don't want to check if other equals 0 is because you could multiply it. Oh yeah, we could just raise it to a, that's right. That's right, it is just, there's no other scenario where, because you can't multiply it by or raise it to a power of a unit. So yeah, we are just checking 0. Yeah, that is a fast way of doing it. I guess I felt like I wanted to keep the checking consistent by checking the result at the end. Are the dimensions at the coming out to 0? Because that leaves the door open. Is there another way that the dimensions could come out to be 0 beyond just raising it to the power of 0? But with the power operator, I don't see how there's any other way of doing that. No. You could raise it to the power of negative. You could, if you had something squared and you raised it to the power of -2, then it would come out 0 again. That's why. Yeah. All right. Good evening. Oh, hey, good evening. Yes. What's the target point of this lecture? The target point is not so much of a lecture. It's just for me to update my package just so you see me watching me do it. That's all. Nothing really happening. Is it for data science or ML or something else? It's for structural engineering generally. Well, sorry, that's not true. It's for any time you need to. It's for engineering purposes. So no matter what kind of engineer you are, if you are commonly doing a series of calculations where with quantities, then that's what for all people is for. There are other more robust unit packages out there, like Pint specifically. And I say more robust as in it can handle a wide variety of things, but it needs to be configured to do that and to be sort of convenient to use. Whereas for all people is designed to be configured very little, and it's just always set up in the state that you want to use it in. So that's the reason that I created for all people, is that I'm a structural engineer. I want to be able to just load up my structural engineering environment and go. and not worry about like having to define units or how they're going to reduce or how they're going to be formatted or anything like that every time that I do a series of calculations. So that's the point of for all people. All right, sound is okay now. Great, awesome. So that's the thing there. Now it's not for ML because you're going to be needing to use NumPy for that, and for all people is sort of partially compatible with NumPy and pandas, but not only in a superficial way, not in a sort of a deep way. That's something that I want to sort of work on in the future as well. But that's going to get more complicated now because not only do I have to make it sort of compatible with NumPy, I also have to make it compatible with the arrow data specification for pandas. So I'm not too sure how to approach that yet. So I'm going to leave things as they are right now in that regard. Okay, so I've updated my GitHub Actions here. I published it. Let's pull the new branches, the new changes. Oops, that's not the branch I want to pull. No, I don't want to publish that branch. I want to just pull it because I've already deleted the branch. There we go. Fetch origin just now. So did I complete this? Merged? Yep. Okay, and now let me just check my GitHub Actions on my local code because I expected it to. Here we go. Published that YAML. Yeah, there we go. So I'm on main.py and I see all the changes. Good. So I'm going to go delete that branch. Oops. Delete. There we go. So the 0 checks passed. That's okay. And now let's go back to the main repo. So now I want to get ready to publish a new release. And what am I doing with this release? I'm not adding any new versions. I'm just fixing the behavior. So that is going to be a patch version. So not 2.7, but 2.6.6. So now I've got my GitHub Actions in there for what to do when a release is created and it gets pulled. This gets happened. Release is published on release. So will trigger that action. So now I'm going to go back to for all people, and I'm going to go ahead and create a release now. But before I create a release, I'm going to create a release branch. This is a practice I've gotten into the habit of using lately, and I find it terribly convenient because it allows me to sort of go back to the state of any previous release and release a fix for an old release. Add a hot fix for a new release without it sort of changing the main branch. I can sort of just update that one branch, and then I can bring that change from that release into the main if required. But if it's like an old release and I want to just patch an old release, I can just update the branch. So with the release on it. So I'm going to create a new release branch here. It's going to be called releases. This thing of like putting a / here it doesn't mean anything, but it kind of gives the illusion of you've got like directories in your branches, right? And so when you see your branches like named releases / something, then you know that it's in like the releases folder. So it's you can do. I've gotten to the habit of using features, fixes, chores, and releases. So version 2.6.6. Is that what it is? Yes, that's right. Okay. So create a release branch, publish the branch. Now this is built off of the main. So the main is current. So the release branch will be created off of the current state of the main. Now I need to do some changes here before I do the release. And that is that I need to bump the version in the code. And that should be under the init.py file. The version should be at the top. Oh, come on, mouse. Here we go. Ooh, 2.6.7. Why does it say 2.6.7? Is that the version I was planning on going to? Oh, am I on 2.6.7, but I didn't do a release since 2.6.5? Ay, ay, ay. This is a problem. Let's fix it. Okay, so it looks like the current version is 2.6.7. And so I'm going to create a new branch. Delete this one. Create a new branch. Releases version 2.6. I feel like I'm airing my dirty laundry right now. This is the state of my repo that needs to get fixed. And I'm going to get onto this track now of being in good state. All right, 2.6.8. That's the new version number. Okay, create that branch. Delete this branch. There we go. Okay, 2.6.8. I've changed it. Now, I haven't committed those changes aren't on disk yet. I haven't saved the file, so I'll save the file. And I'll see the change here. And I think I've also got a version, in my current projects, I also have a version listed in the README, but I do not have it in the README here, but I will have it in the README once that new pull request is merged. So I will just leave that for now. Is there anywhere else I need to update the version or do anything else? No, I don't think so. That's where I have to update the version. Okay. And let's just make sure that that installs properly. So get status should be on my new branch here. And I am going to do a flit install --pth file. And I should see it at the end of all this junk, say uninstalling, oops, I'm going to do flit install without the pth file. All right, is pip out of date? That looks like it. Here we go. Uninstalling, found existing installation 2.6.8. Successfully installed. Okay, so this, yeah, okay, now I'm getting this all fixed up now. This looks like I had 2.6.8 written there previously. Or 2.6.8. I had installed this. Had I installed this by the time? Why is it uninstalling 2.6.8? Okay. This is going through and, as I said, airing my laundry. Oh, okay, now I'm going to figure out what to do from here. Now, the question I need is, what is the version on my main branch here? Let's find out quickly. What does this say? 2.6.7 is what I'm expecting. Bingo, that's what it says. Great. So everything's fine. I now have 2.6.8 installed. I'm going to go back to having it an editable install with the path file. SI meter squared, you would need to multiply SI times SI, yeah, that's right. Yes. Right, and that would be covered. That would be covered by multiply. Thanks for that, Cole. You is right. Yeah, for sure. Okay, so flit install is back done. Yeah, because if you raise it to the power and then to the power, that's like a different thing. Okay. Let's go back to publish the branch. Okay, so publish the branch here. Yes. All right, nothing else I need to do. Oops. I need to commit this though, which is first is a chore, and I'm bump version. Okay. There we go. Now, oops. Oh, it's on this branch. There we go. Let's go back to that. Okay, release 2.6.8. Okay, bump version. Great. Well, there's one other thing we need to do, which is I need to black my code here because it's going to, the black check now is going to say, hi-oh. We're going to change some stuff here. So let's just go ahead and do that and see what happens here. Here we go. This branch has not been deployed. Nice. Okay. Let's see some checks fail. And then I believe that they're just going to be black failures. Here we go. Let's look at one of these. Now, the cleanest way to do this would be for me to go and create a second branch, blackify that, merge that into the release branch. I'm going to think, but because I'm in the process here of just getting everything cleaned up all in one go, I'm just going to go ahead and blackify my release branch. Now, typically you don't do anything else in your release branch other than like just bump the version and push it out. Everything else should be sort of done before that. But in this case, because I'm in the process of just cleaning everything up and things are a bit of a mess still, I'm just going to go ahead and blackify my existing code base in the release branch. Black for all people. There we go. So those are all changed now. I will do this pull request, and we'll see the updated. Oops, gotta push it first. There we go. So these are all the changes that were made. So in this case, it just it looks like it removed a blank space. It removed parentheses that were unnecessary. It doesn't like it when I do just dot. Oh, for goodness sakes. 1 dot, 1.0, fine. Okay, whatever. Okay, no big deal. Oh, except I got to commit push those. Blackify, chore, blackify. Okay, so now I see the change here. Let's see if everything passes now. And the whole point of this is so that you're not publishing software that doesn't pass the required checks that you would expect to be able to pass on somebody else's computer on a fresh install, right? Oh, what's happening? Do I have an old version of Black maybe? Yes. Yes, I do. So there's different formatting choices that be made depending on different Black versions. So my version of Black is out of date. I'm going to update it. Black and you upgrade back in this environment. What did I have? 21.3. Now I've got 22.6. Now I'll do blackify. Black for all people. There we go. What are the changes? Oh, removed a blank line and removed another blank line. Okay. So let's go ahead and chore Black new version. All right. So is this Black formatting thing critical to the code base? No, but if I say that I'm using Black formatting, which I don't have a badge there saying I'm using it yet, but the whole idea between using a formatting tool like Black is that, and especially Black, is it's designed to make the smallest diffs possible. So when you make a change to your code and you run Black on it, then it is only showing you the changes that are meaningful. It's not showing you like, oh, somebody put in extra blank space. No, because Black will remove that extra blank space and only show like sort of the quote pure code. So any changes you make, you're seeing only the changes that are meaningful. And so the idea with Black is that you always run it on basically on every commit, really. And so that way, every time you see your diffs in your Git history, you are seeing just the absolute minimum changes, not like, as I said, white space being added or, white space being added, I think primarily, or sort of line breaks being added in your code. Not meaningful changes, but it looks like a lot of code change when you see it all in a Git diff. Great, all the checks have passed. Let's go ahead and merge it now. So I'm merging my release branch back into main, so that way my main is updated with the current version. But I'm not going to delete my release branch. Some people do, I don't. I like to have my release branches always there, so that way I can always go back to the state and people can always go and see the state of the code at that current release. And I think for engineering software, this is particularly more important and useful, because if you ran a bunch of calcs using a certain version of a software and you were like, oh my God, there was an error in it, let's go, or where we suspect an error is in there, let's go and see the source at the state it was for that version we had installed. And so if the repo always keeps the previous, like all the old version numbers as branches, you can just go there and read the source code in the state that it was at that you installed it. So I'm a big fan of keeping release branches around. So there we go. Pull request, I've got the ones hanging out here. The release has just been merged, so now I'm going to create a new release and draft a new release, choose a tag, create a new tag, version 2.6.8 is the version I'm on, just as a reality check, a sense check, so I don't make a double mistake. Yep, 2.6.8. And then target, I'm not going to release off main. I could, but I'm going to release it off my release branch. And so this is version 2.6.8. And then look at this. I only just discovered this recently. Generate release notes. Very cool. So all the changes that have been made since your last release is now done. And these are all based off of like those commit messages. Yeah. So this is like why it's like valuable to do decent commit messages, because it explains all the stuff. All right, so new contributors, Phil Vivant, one of my students. We did this as like a tutorial for how to contribute to an open source repo. And full change log, there we go. Set as the latest release, publish release. And now here's what we want to have happen is now on this release being done, GitHub Actions should run and publish to PyPI. See if there's any errors. Creating a new Python environment. Setting up Python, install dependencies, install pip. It's installing all the docs building stuff. That's okay. Build package. Good, good, good. Uploading for all people. Done. And now, when we go to pypi.org, there we go. Less than 20 seconds ago, you got the latest version. So you can go ahead and pip install the latest for all people, and you'll have that new behavior. Now, it's 11:15 my time, and I said that I was going to start working on this new feature here. So we're not going to get very far into that before 11:30, but I'm going to just sort of talk about the approach here. Let's just kind of review it together. All right. So what is the goal here? The goal is to have our environments here have an additional sort of, let's say, okay, so let's say I'm in the US and I'm wanting my forces all to be in pounds. And no matter if the environment sort of resolves the factor correctly, I don't care. I just always want to see my forces in pounds. I want to be able to add a thing like this. Oops. Where you go, default is true. Oops. And so now, anytime for all people sees a dimension of kilogram meters per second squared, and if the factor works out, it will match it against the factor. So if you got a factor of kip, it'll match it to kip. But if it doesn't find the factor, then you can always have it in display in pounds. Now, do I want it to sort of override if you have a factor of kip, do you want to see it in kips? Or I feel like you should. I feel like if you've got things in units of kips, you should see it in kips. And like with a factor of kips and it's working. Otherwise, switch to pounds or your default if the factor doesn't work out. I think that's the way I'm going to do it, because otherwise it's just too weird and it sort of implements breaking changes, I would say. Yeah. So now we're going to end a default. Now, does this implement a breaking change? That's an interesting question. So the whole idea is, will your code that you were running before this change break with this change occurring? So what would you have done before? So let's say you're working in US units and you are getting values coming out as kilonewtons, let's say, or newtons. And so your code would then say, here, let's type it out instead of me just talking about code with the blanks with a screen here. Let's delete all this junk. here. So the idea here is if you've got a equals 5 times si.kip, let's say si.pound, and you did something to lose the factor. Oops, that still works. Let's try doing foot. There we go. So you lose the factor, and now it's going into newtons by default. And so if you wanted to, oops, si.fit, it's also changed because of blah, blah, blah. Anyways, it doesn't matter. So we're back in newtons, and now we need to figure out, like, okay, if we wanted this to be in a default, right? So let's say now the default is working as pounds. We set the default to pounds and it's working. But before that, we would have gotten this guy and we would have assigned it, we would have done something like this, and then we would have done the to method and then would have said 2 pound. Now, if that changed and it became the default, pound is the default, and you do .2 pound on it, that doesn't cause a problem. So this whole thing now evaluates to this value in pounds. Now if I do .2 pound on that, this is effectively what we'd be doing. It still works the same. So this would not be a breaking change because it doesn't affect any code that you've written. Even it would just make certain things that you've done in your code redundant, but it wouldn't break, I don't think. So that's what you would have done to kind of force your unit back into the default. You would have assigned the default unit to it manually. So, and doing it twice doesn't break it. Therefore, I don't think it's a breaking change. So that's the behavior I want to have. I want to be able to add into any of these units here, default equals true, and I could even put it into kilonewtons and say default is true, and then have it sort of automatically scale. That would also be nice, although I think that might be a different mechanism. So I'm going to go with this in 2 parts. First is I want to make sure that I can have a default attribute into a derived unit with a factor, and that works out. And then I want to check to see if I can do that with kilonewtons. So it might actually just be as simple as treating kilonewtons as the same as pounds and have it work out. So we'll find out though. Next up, all right, so how do I work on that? So if I'm making this change here, let's undo the change. So I've got no changes in this file. Actually, you know what? Let's do it like this. Let's put those changes back. Let's use git to do that. That's kind of convenient. All right, so I haven't saved this yet. So let's say I saved it. And I'm not on another branch yet. I'm on the release branch. So let's move those changes out of my release branch. I don't want that there. Let's go back to my main and bring my changes back to main. I also don't want them in main, but it's better than my release branch. And so if I don't want these changes and I don't want to like undo a bunch of stuff, you can just do this, right click and discard changes, and then it reverts it back to its original state. So now you don't see the default anywhere. All right, so let's think about how is it going to work with this environment checker. So environment.py here has this environment class. Now this environment class does a bunch of fancy stuff to like check the factor, the dimensions, values, and to like load the environment into the namespace and to check to see if your units are one of the sort of quantities defined in the environment. So where do we do that? Load environment, it's not there. Call, environment.call is where we do the checking. Units by factor, units by dimension. Here we go. So if not environment name, SI, okay, so what does call do? SI.environment. We can do that in our, here. So we've got SI.environment. Now when we call it, this is what we're doing here. We're calling SI.environment. It's a class, but it's callable like a function. And the reason it's callable like a function is because we create a magic method called call on it. That basically these are now the parameters of the function, but it's sort of can run code as though it's a function, but it's still a class. So it can access information stored within it and use that as part of its implementation, which is sort of the benefits of a callable class. It's like a callable class allows you to sort of write a function that is able to sort of retain state, as it were. So a regular function retains no state. You just give it inputs, it does some computation, spits the output. A callable class, you can store some data into the class, and then the function output will be different depending on the state of the class, or the state of the data inside. So in case of this case, I want the data inside to represent the environment that's been loaded from like as a dictionary. And depending on what's in that dictionary will change the behavior of what SI dot environment will do when you call it. So if you don't pass an argument here, it will just tell you all of the units that are in your namespace right now and what their values are. So joules per meters squared. And then I've also got kip inch, KSF, all that sort of stuff. So this is what's in my environment. I should have also just make this bigger here. And that's one way of using SI.environment, is to just call it and it shows you what you got. Let's see, how else do we use environment? Okay, so calling it sets the environments, it pushes the variables to the namespace. So that's not call, which is what I want. I think that I just simply am checking. I'm getting the dictionaries from the environment when I check the module. So let's go back to physical here. Init.py. And where all this environment business happens, it all happens in one method. So when you look at it, inspect a variable here in forallpeople like this, like just this part here, putting A in a cell and doing, enter A and like inspecting it and looking at its representation, the method that gets called to do that, and this is actually returning like it's displaying as an HTML output. The method that does that is this repr template. Now, these are all magic methods that mean something to Jupyter, but mean nothing else anywhere else. And these allow Jupyter to render your output in HTML and do these nice representations there, just sort of by default. Now, all of that happens, and the behavior that gets programmed there is all in this repr template. So the act of like taking a unit here, like A here, but if we do A.repr, the fact that it's got an SI base unit value of 22.24 blah, dimensions of kilogram meter per second squared, a factor of this, precision 3, all of that, the ability to sort of recognize that this is a force with this factor, which we're going to recognize as a pound and then display as a pound, is where all the complicated stuff of forallpeople occurs. And all of that complicated stuff happens when you say, all of that complicated stuff happens when you display it. So you do A like that. All the intense part of forallpeople, all the really complicated stuff, it happened just there. And this, just displaying the value in a way that you expect to see it, that's the complicated work of forallpeople, ironically. So I say ironic because you'd expect it to be something more, right? But just displaying it is the hard part. So that's all gets taken care of in repr template. And now of all the code in forallpeople, this is, I think, for the most organized because this is where all the hard work is. And I've organized the heck out of it to make it very clear for me when I go back to work on it, and also for anybody else to understand what each of these steps are. So it all happens in steps. The important part, the first thing here is the powers of derived. This will tell you whether or not you've got kilonewtons or kilonewtons squared or kilonewtons cubed or kilonewtons to the -1. That's all done with vector math, and that you want to call this once only and then pass the result of it to all the other places where you need it. So that's how you sort of get it faster. All right, so format the units. Let's see. Determine if there's a symbol for these dimensions in the environment, and if the quantity is eligible to be prefixed. Okay, so PHF, which is physical helper functions, evaluate dims and factor. This seems like the key part here. So everything else here is get the appropriate prefix, format the exponent, format the unit. So this is all string formatting, blah, 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 returning the formatted value in the template. Look at that. All of that gets evaluated to return 5 space LB. So let's go back to physical helper functions now. evaluate dims and what's it called? Evaluate dims and unit. Oh, I can go into, I don't need to do that. Where is it? Init. Let's go back up here. Here you go. Evaluate dims and factor. Oh, I should be able to go to definition. Here it is, F12. Excuse me. Okay, dims original. So get units by factor. Okay. So now it's in here where I need to do a check for if it's a unit if there's a default unit or not. So I think, so what I do is I get units by factor. So this generates get units by factor, pass it the factor, pass it the original dimensions, the units environment, and then the power, and that tells me whether or not I got a defined unit or not. And if that's none, and then I also check to get a derived unit. So this is like SI, this is like pounds or US units or anything that's got a factor attached to it. This is for like SI units that are like kilonewtons. And then dims basis multiple, this determines whether or not it's one of these, like if it's just like kilogram or just meter. So I've got all this logic here. So if it's not a defined unit, which is like one of the factor, so if it doesn't find it there, if that returns none, then this returns none or something like that. Yeah, if derived, yeah, if it's falsy. So I need to change the behavior of get units by factor to see if there is a default as part of that. So let's highlight that and go to that definition, F12, get units by factor. And new factor, fraction of the powers, match factors. And you know what the nice thing is? If there's default units, I should be able to just check dimensions. And then I might be able to sort of miss some expensive math. All right. Okay, so getting towards the end of this stream here, 11:30 is where I said I was going to stop, and I'm going to stick to that. So that's my dirty laundry and for all people. So you got to see me sort of get things a little bit more modernized. I've got GitHub Actions now in there. I've fixed a bug it's nice to fix, and I've got an open PR that I've made a comment on. I need one small change. Now, I could have pulled that PR and then just manually changed it myself, but it's nicer if the contributor does it, because now their change is more meaningful than if I like accept it, then I go ahead and change the work that they did. It doesn't feel as nice, right? It's like going and sweeping somebody's living room after they've already swept it. So, yeah, so I'm going to allow them the opportunity to make that minor change and then pull their request in, and then it'll be a little bit nicer on a README, and then there'll be a link to the actual documentation. Like, this was something I was going to do today, but if that pull request weren't there, then I would have done it already. But I'd rather have contributors than no contributors. So this is the For All People documentation, connorforster.github.io/forallpeople. You'll notice there's no link anywhere to it. My bad. And but it describes and answers a lot of questions that people have. So I spent a fair bit of time putting this together, and I'm going to spend some more time probably updating it as we sort of get into new features of For All People. All right, so that is everything. If people don't have any other questions, then I'm going to sign off at 11:29. All right, so I'm hoping to do more of these live streams. I'm going to try and do one of these every week. Maybe next week we'll continue on with this For All People stuff. I'll make some notes about where we left off and then pick up right from there. All right, cheers.